Next, let's take a look at some basic types and look at some basic operations with types. The simplest possible type is probably the char, which stands for character. And on almost every machine, and I have to say most machines use these sizes and ranges, but it's not going to be true for every single version, every single C compiler. Some hardware is gonna probably use something different. I just know that from experience, having used many kinds of hardware. So having said that, I think most of the time you'll find all of these things to be true. So most of the time this will be true. You might run into some special cases where some of these things may not be exactly true. Okay, so a char is 1 byte or 8 bits, and therefore you can have any number that that falls within. You can represent at the most 2 to the power 8 numbers. So 2 to the power 8 is 256, and so you can spread that between negative numbers and positive numbers, or you can make sure that you can make that all positive numbers if you used unsigned chars. This is a different type. We don't have this in Java, but we do have this in C and C++, in Objective-C and C#. So an unsigned char means that you do not have negative numbers, essentially. What it really means is that the most significant bit is not interpreted as the sign bit. So that is, if the most significant bit is 1, if you have a char, that's interpreted as a negative number, and so that's why you can go between negative 128 and 127. You might ask, why can't you represent 128? Well, you don't have enough bits to represent that. And this gets into a lot of stuff that we will find out more about in a course called Computer Organization. That's Computer Science 355. So let's leave that for a minute. Just take it for granted that a char is 1 byte, so the acceptable range of values that you can have for a char is between negative 128 to positive 127. Those are just, and that's true for C++ as well. An unsigned char is like a Java byte type. It's also 1 byte, that is 8 bits, and so those values go from 0 to 255. That's a total of 256 values, and that's 2 to the power 8. Java also has short, so does C, C#, Objective-C, all of those things. So a short is almost always it'll be the same as a short int, which is 2 bytes. And 2 bytes means 16 bits, and so you can have 2 to the power 16 total number of values, and 2 to the power 16 is 65,536. And if you were to consider all the values between negative 32,768 to positive 32,767, there's that same thing that you'll see this pattern over and over again, that there's fewer positive numbers than negative numbers, and you'll learn all about that in a future course, but you'll see the same pattern. So this is a total of 65,536 values. If you have the unsigned version, and you cannot do this in Java. So in Java you cannot create unsigned variables or primitive data types. You can, of course, sort of mimic it, but you cannot. By default, you have shorts, and they have a sign to them. Okay, and shorts in Java are also 2 bytes, and they go from the same range, and so unsigned shorts, and that's only in C, C++, Objective-C, C#, so on. They go from 0 to 65,535, and if you check it out, add 1 to this, this is the same as 2 to the power, that would be the same as 2 to the power 16. Okay, so there is a pattern, and you can, once you know about how binary works, all of this makes perfect sense. So right now, it might look like just a bunch of numbers, but once you get used to binary numbers, all of this, you will see that there is a method to this. Okay, so you can have char, you can have short. Next up is int, that's 4 bytes. Typically we don't have a type that's 3 bytes long. You might ask why. It has to do with the memory and once again, how hardware works, how binary hardware works. So 4 is the next biggest thing, and so this goes from roughly negative 2 to the power 31, I believe, to almost positive 2 to the power 31. You can also have unsigned ints, and that means you go from 0 to some large number, and that's roughly 2 to the power 32. Actually, this is this value is 1 less than 2 to the power 32. And this will be important. This number is actually pretty important, because it represents the maximum number that you can have, the largest number that you can have in an int, and that's an important limitation. If you use 32-bit data, 32-bit systems, you're limited to roughly 4 billion numbers. Okay. After that, you can have long, which in most systems that we will use, it will be 4 bytes. And you might ask, well, why is this 4 bytes? Why don't we just use an int? Yeah, you can use an int. And it's not, on almost every system, it will not be different. A long will not be different from an int. So this is different from Java. In Java, a long is 8 bytes. To get an 8-byte integer in C, you have to use long int. And that is 8 bytes, and that goes roughly between plus and minus this huge number, which I cannot remember exactly how big that is. Floats are 4-byte floating point numbers, so float refers to floating point, and so you can have that decimal point be anywhere. Roughly, you can go between positive 10 to the power 38, and the smallest positive number you can have will be 10 to the power negative 38. That's a very small positive number. The largest negative number will be negative 10 to the power minus 38, and the smallest negative number, that is the smallest in the sense that the most negative number, will be negative 10 to the power positive 38. I hope that didn't confuse you, but go over that and it'll make sense. Double, although you might have used float and double in Java, you may not be familiar with where this term comes from. Float just means floating point number, and so in the very beginning, people who wrote compilers, or actually it was a Fortran programming language, they said, all right, 8 bytes should be enough to represent most meaningful floating point numbers. And it turned out that you can get more accurate results for when you solve things like differential equations or matrices, things like that. If you double the precision from 4 bytes to 8 bytes, you can get a lot better precision. And 8 bytes is pretty much all you need in most situations. And very rarely you might need more, but typically 8 bytes is good. So it turns out that's double the precision of float, which is single precision. So that's why we call it double. So you might have wondered, why do we have things called double? That's because you double the precision. And when you double, the largest positive number is 10 to the power positive 308. That's a massive number. And then the most negative number would be negative 10 to the power positive 308. That's a very large negative number in some ways. And the smallest number would be positive 10 to the power negative 308, roughly. Okay, so I'm hoping that makes sense. I know it's a little, maybe not completely straightforward, but actually once you get used to binary, I'll say this over and over again, if you know how binary systems work, if you know how hardware works, these numbers make perfect sense. Okay, you can also have long doubles. Typically, we don't use that. And one more thing I want to emphasize is that all of this can vary with CPU, compiler, and compiler options. So you can actually change what, for example, long means by using compiler options. So that is possible. Okay, next let's take a look at constants. C has literal constants just like Java, and that just means 365 refers to the sequence 365 refers to 365. So 365 is called a literal constant, so is 3.1415. That's a floating point constant. You can also have single characters or strings. Those are all literal. Those are called literal constants. Typically, we would use a pound define to say that this, for example, pi is 3.1415, and you can have additional digits or additional digits of accuracy. It's often, although this is not required, almost every pound define will use uppercase letters just to avoid confusion. It's not required by the C preprocessor that you use uppercase, but if you use lowercase, then you might run into problem situations, because what's going to happen is all this pound define does is takes every occurrence of this name, pi, and replaces that with whatever comes after it. So every occurrence of pi will be replaced by that. If you use lowercase characters here, might mess up your code. So you want to avoid using lowercase characters in pound define just to avoid confusion. Okay, so C, like in C++ and Objective-C, also has const. That is like Java finals. So this would be just like a Java final. You say const float pi equals 3.1415. And this is true in all the compilers that we will use, but you may not find it in every single compiler. So if, for example, you use some embedded system, it might be possible that that system will have a C compiler that does not recognize consts. Hopefully we don't run into that situation. C has the usual arithmetic operators, the same kinds of precedence rules. So for example, multiply, divide, those are higher precedence than addition and subtraction. Higher than multiply is unary, so -5 has higher, that minus and -5 has higher precedence than the multiply or divide. And even higher is post-increment, pre-increment, and so on. You have the same kinds of operators that you might have seen in Java or C++. Star equals, that means if you say x star equals 5, that's the same as x is equal to x times 5. So that kind of thing for also divide and the mod or remainder operation.